Hey guys, it's Miss K. Happy Tuesday. I hope you're doing well. I decided to try something new today and actually record this video sitting outside in the back of my house because I just needed some fresh air. It's a little bit cold, but it's worth it to me just to feel the air. So if you hear noises like trucks or things in the background, that's what it is from the street. So, okay, we're going to start by going over the follow-up problems that I left you with from last Thursday. All right, so the first number, 34 and 482 thousandths. If I want to round that to the nearest whole, I want to think about what place value I'm talking about, and that place value that I'm talking about is the ones place when I talk about the nearest whole. Since there's a 4 next to it in the tenths place, that's what I'm going to use to decide what whole I'm rounding to. 4 is less than 5, so that number 34 is going to stay the same. So to the nearest whole, it's 34. Now, let's look at the nearest tenths place. There's a 4 in the tenths place, but to decide what happens to 4 tenths, I have to look next door to the 8 in the hundredths place. Since 8 is much larger than 5, that 4 tenths is going to bump up to 5 tenths, so this number rounded to the nearest tenth is 34 and 5 tenths. Now, if I want to round to the nearest hundredths, I'm going to look in the hundredths place and see there's an 8. I'm going to look next door to the thousandths place and see there is a 2. 2 thousandths is less than 5 thousandths, so that 8 is not going to move anywhere, and this number rounded to the nearest hundredth is going to be 34 and 48 hundredths. Now, let's look at the next number, 99 and 909 thousandths. This number is a little bit tricky. I'm actually going to start with the tenths place here and come back to the nearest whole. So if I'm looking in the tenths place, I see there's a 9. I'm going to look next door. I see there's a 0. A 0 isn't going to change the value of that 9, so it's going to stay at 9. So if I round that number to the nearest tenths place, I get 99 and 9 tenths. Now, let's talk about the nearest hundredths place. There's a 0 in the hundredths place. So right now, that number is not going anywhere. But if I look next door to the 9 in the thousandths place, I see the 9 is large. It's way over 5. So instead of having 0 hundredths, that number rounded to the nearest hundredths is going to be 99 and 91 hundredths. Now, let's go back to the nearest whole. This is kind of tricky. Remember, when I'm rounding a number to the nearest whole, I'm talking about the ones place. The ones place here has a 9. Okay. Now, I look next door to the tenths place to decide what I'm going to do with the ones place, and I see there's also a 9. Okay, we know it's more than 5. We know we have to bump up that 9. But here's the problem. The number that comes after 9 is 10. We cannot fit 10 ones in the ones place. So we're going to go up another place value to the tens place. Guess what the problem is again? There's a 9 in the tens place. So now we got to go up again to figure out a place to put that 1. And sure enough, 99 and 909 thousandths rounded to the nearest whole number is 100. That one's pretty tricky. Let's look at the next number, 5 and 555 thousandths, rounding to the nearest whole. So I'm looking again in the ones place. I see there's a 5. I see there's a 5 in the tenths place. Okay, a 5 is going to make this number go up. Okay, push it up to the next value. 5 makes it closer to the next whole number, so this is going to be 6 wholes. Now I look again, if I want to round this number to the nearest tenths place, I see there's a 5. I look next door in the place value of the hundredths. I also see there's a 5. That 5 is going to bump this number up, so rounded to the nearest tenth is going to be 5 and 6 tenths. Now, let's look at this number again. I'm thinking about, what is this number going to be rounded to the nearest hundredths? I have a 5 in the hundredths place. I look next door again to the thousandths place, I see there's a 5. That 5 is going to get bumped up to a 6. So instead of there being 5 hundredths, I'm now going to have 6 hundredths. And the rest of the number, I'm not changing the value of those digits, is going to stay the same. So I have 5 and 56 hundredths. Now, let's look at this number. And I want to round this number to the nearest whole. Okay, I'm going to look in the ones place. All right, I look next door, there's a 5. Okay, I know that number is going to get bumped up. Now I'm thinking in my head, what comes after 9? 10. Ooh, 10 can't fit in the ones place. It's too many. So I'm going to go up one more place value, and I see there's a 1. So that's going to bump up 2. So 19 and 509 thousandths is going to round to 20 wholes. All right. I'm talking about rounding this number to the nearest 10th place. I look in the 10th place and I see there's a 5. Next to it, there's a 0. So that 5 is going to rest. It's not going to go anywhere because it has nothing to be bumped up for. So this number rounded to the nearest 10th place is going to be 19 and 5/10. Finally, if I want to round this number to the nearest hundredths, I see there's a 0 in the hundredths place. Okay, right now there's nothing. But if I look next door, there is a 9 in the thousandths place. The 9 in the thousandths place is going to bump up that number. So now instead of having 0 hundredths, I'm going to have 19 and 51 hundredths. Now, I know there was a lot of explanation here, so if you need to stop and play it again, it's a good idea to check with your answers that you got on Friday. All right. Okay, so now we're going to start the warm-up today, and what I want you to do in the warm-up is either use equal signs, greater than signs, or less than signs to compare these numbers. So 67 hundredths and 67 over 100, what do you think about that? 83 hundredths or 84 thousandths, 328 and 2 tenths, or 328 and 99 thousandths, 4 and 7 hundredths versus 47 tenths. And then the last comparison is 24 and 9 thousandths versus 3 tenths. So now would be a great time to pause the video and go ahead and solve this on your own. Once you are done, hit play again and we'll go over it together. All right. Let's compare these numbers. I have 67 hundredths and 67 over 100. These are equal. One is in decimal form and one is in fraction form. This one, 83 hundredths or 84 thousandths. Now, if I wrote this as a decimal, it would look like this. So you could clearly see that this number has an 8 in the tenths place, but this has a 0 in the tenths place, in which case 83 hundredths is larger or greater. The next number, 328 and 2 tenths, or 328 and 99 thousandths. So remember, we talked about this like a week ago. We want to compare them by place values. So the 3's are the same, the 2's are the same, the 8's are the same. Those all have the same place value. So the next place value where there's a difference is the tenths place. And we have a 2 versus a 0. And because this number is 2 tenths and this has 0 tenths, we know that this number is larger. And they try to trick you because this number has a lot more digits, which would make you think that one would be bigger, but that's not true. This one, 4 and 7 hundredths or 47 tenths. So I'm going to write 47 tenths for a second as a fraction, which I did there. And if I did that, I can change that to a mixed number, which would be 4 wholes and 7/10. And that's 4 wholes and 7/100. So even if I wrote it now as a fraction, in decimal form, I have 4 and 7/10. You could see the 7 in the tenths place is larger than the 0 in the hundredths place. So 47/10 is larger. The next number, 24 and 9/1000ths, or 3/10. Okay, so I have 24 and 9/1000. So 0 in the tenths, 0 in the hundredths, and then 9/1000. And then I have 3 whole tens. So if you think about it, this isn't tenths, this is tens. So 3/10 is the same thing as saying 30, right? So 3/10 is larger or greater. All right, here is our Buc-ee's challenge for today. It's swimming a 100-meter race. Now I'm going to tell you right now, these athletes here are very, very fast. They're swimmers who are probably college swimmers or even athletes that are training for something, not quite the Olympics, but they're very, very good. So there are 5 athletes here, and they swam a 100-meter freestyle race, which is like front crawl stroke. And you see their times are listed, okay? Their times are in seconds. So this means it only took them a 48 and a little bit more seconds to get to the finish line. So here's our challenge for today. We want to think about 3 things based on the time in seconds of these 5 athletes. How would the results of the race change if the times were recorded to the nearest second? How would the results of the race change if the times were recorded to the nearest tenth of a second? How would the results of the race change if the times were recorded to the nearest hundredth of a second? So here's the deal. These are the times that the athletes got. We want to see, would the times change if it was recorded to the nearest second, to the nearest tenth of a second, or to the nearest hundredth of a second? So, as usual, Notice and Wonders, I want you to pause it. I want you to take 5 minutes and write down everything you notice and wonder about this big problem. All right, here are my notices and wonders. Check them with your own. Maybe you have ones that I didn't think about. Notices. There are 5 athletes competing in the race. They are measuring the time in seconds. Each athlete's time has the same amount of digits. The last digit for all of the athletes is in the thousandths place. Each athlete has a time of 48 seconds, meaning the numbers before the decimal are all the same. We have to record the times in different place values. That's what the problem is asking. The place values we must record the times in are the nearest second, the nearest tenth of a second, and the nearest hundredth of a second. We want to order the swimmers from who came in first to who came in last. Here are some wonders. Will the swimmers' times be the same or different depending on the place value we record their time in? Will the winner of the race be different if we record the swimmers' times to different place values? In this situation, what place value does it make sense to record the swimmers' times in? When it asks to record the time to the nearest second, what place value is that? I wonder if the race is close because the swimmers' times all start with 48 seconds. So again, here is your Buc-ee's challenge. 5 swimmers, 5 athletes swimming an 100-meter race. Your job is to record their times to the nearest second, to the nearest tenth of a second, and to the nearest hundredth of a second. That is for all 5 athletes. Now would be a great time to pause the video and take about 10 minutes to work on Buc-ee's challenge. All right, so we're going to start by thinking about what would these athletes' times be if we recorded them to the nearest second. The nearest second means the nearest 1 second, which is talking about the ones place, which is right here. So in order to do that, I want to round these times to the nearest whole second, or round it to the ones place. So this is what I did. I took the athletes' times, all 5 of them, and I listed out the tens and ones, which are all 48 seconds. Now, to round to the nearest second, which is the ones place, using the ones place, I look to the place value next door, which is the tenths place. All right, so let's do it with the first one. If there's an 8 in the ones place, and I look next door and there's a 5, and if I'm rounding it to the nearest second, this is going to round to 49 seconds. Okay, let's look at athlete 2. There's an 8 again in the ones place. I'm going to look next door to the tenths place. There's a 5. It's going to round up again. I get 49 seconds. The third athlete, there's an 8 in the ones place. I look next door to the 6 in the tenths place. So rounding this to the nearest second, or recording the times in the nearest second, it's going to bump it up again to 49 seconds. Interesting. The same thing's happening with athlete 4. I have an 8 in the ones place and a 6 in the tenths place. So this is also going to round to the nearest second to 49 seconds. And then here I have 48 and 7 tenths. Again, an 8 in the ones place, a 7 in the tenths place. It rounds up again to 49 seconds. So if I record all 5 athletes' times to the nearest second, it's all 49 seconds. What's the problem with that? Let's think about it. If I need to decide a winner of the race who came in first, second, third, fourth, fifth, can I do that if all of their times are to the nearest second? I can't. Because if I record their times to the nearest second, no one won the race. They all got the same exact time, which we know is not true. What this does tell you by looking at their times from the nearest second is this race is very, very close, because they all swam this race in approximately or about 49 seconds, which is really, really fast. So the difference between their times are very, very small. It's like almost like they touched at the exact same point. So again, if you're recording their times to the nearest second, everyone got 49 seconds is how long it took them to swim the race. We don't know who the winner is. That is a problem. All right, now let's look what happened if we record these 5 athletes' times to the nearest tenth of a second. A tenth of the second, that means the number will end in the tenths place. To the round to the tenths place, which is what we're doing if we want to list the athlete's time to the nearest tenth of a second, I look next door to the hundredths place. So what I did was I rewrote these athletes' times with just the digits in the tens and ones, and then the tenths and hundredths. So let's start with the first athlete. I see there is a 5 in the tenths place. So I look next door, there's a 3 Okay, the 3 is smaller than 5, so if I'm rounding this number to the nearest tenths, this number is going to round to 48 and 5/10. Okay, let's look at athlete 2. I look at the 5 again in the tenths place. I look next door, there's a 6. 6 is more than 5, so this is going to round up. So that's not going to be a 5 anymore in the tenths place. That's going to push up to a 6. Let's see, why isn't this pen working? And I get 48 and 6/10. Okay, let's look at athlete 3. I see a 6 in the tenths place. I look next door, there's a 2. Okay, that 2 is smaller than 5, so it's going to stay at 6/10. So this athlete's time is going to round to 48 and 6/10 if we record it to the nearest tenths place. Now, let's look at athlete 4. Their time is 48 and 63/100 this way. If I look at the tenths place, I see there's a 6 there. I look next door, there's a 3. Again, that 3 is smaller than 5, so it's going to round to 48 and 6/10. Okay, let's look at the last athlete. Their time, according to the tenths place right now, is 48 and 70/100. If I include the hundreds, so I have a 7 in the tenths place. Seven in the tenths place, and I look next door, there's a 0. So that 0 is not going to do anything to that 7 in the tenths place. So their time will round to 48 and 7/10. So let's look at what we know. Athlete 1 has a time of 48 and 5/10. Okay, I'm going to put athlete 1 on the bottom here. 48 and 5/10. Athlete 5 has a time of 48 and 7/10. So they're 2/10 slower. But here's the problem. Athlete 2, 3, and 4 all have a time of 48 and 6/10. So here's the problem. We might know who came in first. We might know who came in 5th. Okay, but who came in 2nd, 3rd, and 4th right now is all here. So recording the times to the nearest tenth of a second is not even specific enough to see the order of all 5 swimmers. So again, this race was super, super close. The fact that the person in 2nd, 3rd, and 4th place, the 3 swimmers in the middle, have a difference of hundredths or thousandths of a second means they practically touched at the same time. All right, so now we're going to try seeing what happens if we record the times of these 5 athletes to the nearest hundredth of a second. So when we're rounding to the nearest hundredth, the numbers will end in the hundredths place. In order to see what digit that will end with, I need to look next door to the thousandths place. Okay, so let's start with athlete number 1. Athlete number 1 has a 3 in the hundredths place. And I'm looking next door to the thousandths place and I see it's a 2. So athlete 1's time in this swimming race will round to 48 and 53 hundredths. Okay? Athlete 2, if I'm looking in the hundredths place, I see there is a 6. If I look next door, I see there is a 1 in the thousandths place. So that 6 is not going to round up because of the 1. So athlete 2's time is 48 and 56 56 hundredths of a second. Let's look at athlete 3. Just want to make sure you can see this. Let's look at athlete 3. Athlete 3 has a 2 in the hundredths place. So if I look next door, that's a 6. That's going to bump that 2 in the hundredths place up to a 3. So their time is going to be 48 and 63 hundredths. Now, let's look at athlete 4. They have a 3 in the hundredths place. They have a 4 in the thousandths place. So in this case, their time, with the 4 in the thousandths place, 4 is still less than 5, their time is going to be 48 and 63 hundredths. Okay, now the last athlete, if I look at their time, they have a 0 in the hundredths place, but if I look next door, there's an 8, so that 8 is going to bump that 0 up to a 1 in the hundredths place. So athlete 5's time is going to be 48 and 71 hundredths. So now let's look at this. Can I order these 5 athletes in order from who came in first, second, third, fourth, fifth? I can. Look, athlete 1 won the race with a time of 48 and 53 hundredths of a second. Good job. First place. Athlete 2 came in second place with a time of 48 and 56 hundredths of a second. This is second place. Okay, now athlete 3 and 4, they actually tied. Because you don't really record your times in a swimming race to the nearest thousandth, with a time of 48 and 63 hundredths. They came in third and fourth. And then fifth place was 48 and 71 hundredths. Now, if I go back to athlete 3 and 4 and I look at the original chart, you could see that athlete 3 with a 6 in the thousandths place versus a 6 in the versus a 4 in the thousandths place. Athlete 3 is 2 thousandths of a second slower, but again, in swimming, they usually only record times to the nearest hundredths place, so I would argue that athlete 3 and 4 practically tied. But if you did want to put them in order, athlete 4 is slightly faster than athlete 3. So here, by rounding to the nearest hundredths place, it's important, those hundredths of a second in a swimming race, to really tell the difference of who came in first versus who came in last. All right, guys, when we finish any Bucky's challenge, we want to talk about things like we learned. So here are some reflections that I thought were really important. The place value we record the times does matter. Otherwise, we do not know who is the clear winner of the race. If you look at the picture that I just put here are two swimmers that are swimming really, really fast. It looks like they touched at the same time, but by difference is of like hundredths of a second based on what is recorded. That's how they know who got first or second. We can round the numbers to different place values to see the times of the swimmers recorded in different ways. Since this is a close race, the times are very close together. It makes sense to round the numbers to the nearest hundredth. This way we can see the slightest difference in who touched the wall first, second, or third. Bucky has a lot to say too right now. Here's the follow-up problem I would like you to do on your own. A swimmer finished a race in 49 and 256 thousandths of seconds. Determine the time rounded to the nearest whole second, tenth of a second, and hundredth of a second. Now would be a really good time to pause this and try it on your own. Questions. If you have questions about anything I have discussed or have answers to the problems I left you to solve, please email me your responses or send me a message on Dojo. I will respond to your messages in my challenge for Thursday. I also want you to know that I miss you very, very much and would love to just hear how you're doing. So if you have any recommendations of TV shows you've been watching or music you've been listening to or games that you've been playing, please let me know. I would love to hear about it. Hope you're all doing well and talk to you on Thursday. Bye. All right, Bucky, you gonna speak for everyone now? Go ahead, say hi. So after all that howling, you have nothing to say? Okay. Bye, Bucky. Bye, everyone.